Okay, so how do we do this then? Graph and calculator. A couple ways. Okay, one way is we can graph this. Okay, we have to put it into standard form, but we can graph. If we put this into standard form, it does not have to be at all simplified. It just has to equal 0. So if I get everything on the left side, couldn't I just write that as 1/6 x squared minus 3/4 x minus 1/2 minus 1/6 equals 0? I don't have to do anything extra to it, just get it equal to 0. Everything on one side then, this is the function that we want to set equal to 0, right? We want to graph this thing. Well, graphing it and finding out where it equals 0 is the same thing as asking where the x-intercepts are. That's it, right? So on my graphing calculator, I could just go up to y equals, and I could just enter all this stuff is my function. So it's going to be negative. I can even use if I want to, I can use that fraction template if I want to get fancy. So 1/6. I can just put them in parentheses too. It's a lot quicker. 1/6 x squared minus 3/4 x minus 1/2 is 0.5, right? I could just make that as 0.5 minus 1/6, and I could even just put in as 1 divided by 6 if I want to, or I can use the fraction template. But it's all in there. I'm going to graph it by going zoom 6 to start with. I might have to expand my window, but all I'm looking for are the x-intercepts. Well, there they are, right there. Those are the answers as decimals. So all I have to do is go find those x-intercepts. The calculator is going to call those zeros because we're asking where does the function equal 0. So if we just go second calculate 2 for 0, it's going to ask me for the information it needs to track down one of those x-intercepts. So let's find the left one. I need a left boundary. So I can either just trace over to the left, or I could even type in a value. I can see that like -3 would be to the left. Does everybody see that?
How'd you get there second?
Second calc 0. So second calc 2 from the graph. Okay? I can either trace to the left, or I could just enter a number that works like -3 for my left boundary and hit enter. Look what it does. Then it puts my left boundary, it makes a little marker there. My left boundary is right there. That's to the left of that 0. I could either trace to the right or pick a number, but I can't go too far. I can't go clear past the other x-intercept. It's got to be one that's to the right of the first one, but not past the second one. So I could pick a value like x equals 2. Everybody agree? 2. So now I'm only looking between those two marks. And then for my guess, I can either trace into the middle or just pick something like -1, which is pretty close. It's going to think about it, and there it is. There's one solution. It's a decimal. What would I do to find the other one? Same thing. Second calc 2, start over again for the other one. Okay, pretty good, huh? The nice thing about that is that technique works for any kind of function. It doesn't have to be quadratic, it could be anything. It could be a square root, it could be some bizarre exponential function, it could be anything. You can always set it equal to 0 and find the real solutions by just graphing it and finding the x-intercepts. It always works. Okay? It could be one, what if we had one like this that was, well, like that example we had, if I go back a little bit. Let's see, right there. Right, what about that one? All I'd have to do here is just take all this stuff and subtract 11 from it, right? And I could enter that big mess also. I don't have to go through and FOIL that out or anything tricky to put it into standard form. I can just enter it like that and graph it. Does that make sense? Okay, so that's a really versatile way to find to find solutions. Okay, another way I could do this one though, show you another trick. I like the graphing trick almost the best because it's so versatile. There is a function or an app that's built into your calculators or that I can put on your calculators though that's also really helpful. So if you go to apps, and you guys, if you don't have a ton on there, you can just probably go down to the bottom. You want the one called Polysmoke 2. So I've got a lot of apps on here, so I'm gonna go alpha P to skip to the P's. There it is right there, Polysmoke 2. It does lots of things, but the thing that we're interested in right now is the polynomial root finder. Okay, polynomial is something we're going to talk about in about a week and a half. So that's the next unit, but this is a polynomial without you knowing it. So we're going to choose number 1. The order needs to be 2, meaning that it's going to be the highest power of x is going to be x squared because it's quadratic. We can choose real or imaginary, but we just want real here, it's fine. And then we just go down to next. So I hit F5, and it just wants to know what are the coefficients. Okay, so for the coefficients, let me just clear these out. I guess I could have hit clear there. It clears everything. Okay, so then it wants the coefficients. Well, A2 is the number that's being multiplied by x squared. A1 is the number being multiplied by x, and A0 is the number, is the constant. So A2 would just be 1/6. I can just do 1 divided by 6, and it enters it as a decimal. Okay, that's fine. Takes it out to a whole bunch of places. A1 would be -3/4, so -3 divided by 4 makes it a decimal. And then the last one, I can even do -1/2 minus 1/6, and it'll make that a decimal for me. Okay, and then if I just go up and hit solve, there are my answers. Now it's rounded them quite a bit, and I think that's because I probably should have. I think there's a. If I go back here to that one, yeah, see the float right there? I have it on 2. Probably don't want that. Probably we just want it on float, so it'll keep all the decimals. And now if I go next, solve. See, look, it gives me answers with as many decimals as I want. But if I want them rounded for me, I can just pick the number of places I want them rounded to also. Like 3 for thousandths, for example. That make sense? So that's pretty good. But that one wouldn't have worked so well, would it, on a problem like that one? You see why? Because that one's not written in standard form. Okay? So that's one that would have been better to graph. Make sense? Okay, the other thing I wanted to show you on here, though, was how to do, okay, I think I showed you how to do the fitting. I'm sure I showed you this, but let's just make sure. Let's see. Okay, we just did that one. Yeah, what about one like this? Remember how to find that? If I'm trying to fit that into, in the directions, what they said was put this into general form, or standard form. And it told me that I could have decimal numbers for the coefficients, right? So remember what the trick is? It's really simple. If I want to find the parabola that goes through those 3 points, let's get out of here. So I go to main and quit. This is where I can do regression. Just go stat, edit, and put in those 3 points. So my x values would just be -2, -1, and +1. And my y values would be in order 0, 4, -5. Remember this? put in all three ordered pairs. I go stat, calculate menu, which one? What kind of regression am I doing here? For a parabola? Not linear. Quadratic. So I'm going to do 5 instead of 4. Stat calc 5. And that's the answer right there. So A is negative 2.83 repeating. B is negative 4.5. C is 2.3 repeating. It's a perfect fit, 100%. So it's in the form of ax squared plus bx plus c. It gave it to me, just like that. Easy, right? Very useful though. Okay, the other thing on here that's also the calculator does for you, this is really slick, would be something like this. What if I had, let's say, I want to do some arithmetic with complex numbers. Say that I have something like, say it could be hard too. Say I have something like 2 plus 3i cubed plus 3 divided by 9 minus 4i. That would be really hard and time consuming to do without a graphing calculator, right? There'd be a lot of arithmetic to do with complex numbers. With complex numbers though, or with the calculator, look what we can do. We go to mode, go down and put it into a plus bi mode, imaginary mode, okay? And then all I have to do, this is great, all I have to do is just enter that, literally. Now I can't use the fraction template though. That's the one real inconvenience, you can't use the fraction template. So how am I going to enter this on my calculator then? I got to open a set of parentheses for the whole numerator. Then I got to do this quantity cubed, right? So I got to open another set of parentheses for those ones right there. 2 plus 3i cubed, right? Plus 3, close the numerator, divided by the denominator, 9 minus 4i, right? So if we do that though, watch what we get. So parentheses, numerator, parentheses, complex number, 2 plus 3, where's the I? Yeah, it's right behind the decimal point, so second there. Okay, close the parentheses, take that quantity to third power. Okay, get out of the exponent, plus 3, close the parentheses, divide by the quantity 9 minus 4i, hit enter, and look what it does. It gives me back, I can even turn this, if I go math, convert to fraction. Oh, yours will do that though, won't it? Mine won't, but yours will. Am I right? Is anybody doing this one? Yours, did yours do it?
No, mine didn't.
Gave you the same error?
No, fraction.
Oh, it did give you a fraction. Yeah, so yours gave you the fraction. Did yours give you the fraction?
No.
Yours did this also? Okay, so it might be, let me see what the operating system is.
That's on you.
Right. Oh, okay, that's because you got, yeah, you got something weird in there.
Wait, what did I do?
So you got the I supposed to, yeah, you didn't hit you hit alpha instead of second.
Oh. That's not too bad, so.
Okay, divided by, and then here you got that parentheses down at the bottom. 3 minus 4. Now watch this. So you guys, for some reason mine won't work, but yours will. If you hit convert to fractions, it's going to give you that complex number even with fractions, right? Question? Yes. Okay, so Easy, right? Very simple. To do these, I'm going to give you a couple hard ones to do that you will definitely not want to do manually. You want to use your calculator on. Last one. Okay, last one, and this is everything. You guys are totally set to go then. What about something like this? And then I got to take roll. Okay, what if you want to calculate a modulus? If I want to do, and this is really simple to do anyway, but you might as well let your calculator do it for you. If I want to calculate the modulus of 11 minus 3i, what do you think I do? All I have to do is just square, or absolute value, right? So, where is that? Math, number, absolute value. There's my absolute value bars. For a complex number, it's going to know to make that a modulus. 11 minus 3. Yeah, hang on. Eric, go ahead. Hey. Oh yeah. I know. I should have today. I've been lecturing all day and I haven't. Yeah. Okay, I'll tell you. I'll tell you real quick. Let's see. It's got to update real quick. No, I did not. Yeah. Okay. Yep. Okay. So anyway, what do? In parentheses, or in the absolute values, I just put 11 minus 3 second decimal, gives you my I, enter, there it is, okay? Gives it as a decimal, that's okay. On that part of the test, I'll let you give decimal answers. So is there any, how could you not get 100% on that? That's going to be an easy one, okay? All right. I got to take roll. You guys can